Good morning everyone, this is the Year 3 Chapter 2 episode. This one is all about triangles, multiplications and, when we reach the end, even trigonometry ratios. Welcome to Chapter 2. Before we start with the video, a disclaimer. The triangles in this video are not on scale. Yes, I did my best to make them look like they are, but they are far from perfect. In my opinion, they are good enough and that's what counts. Now, on to the video. Last year, you were taught how to use Pythagoras' theorem. So let's check if your memory is what it should be. Pythagoras could only be used in a right-angled triangle, and you can use it to calculate one of the sides of the triangle if you knew the other two. So, in triangle ABC, with angle B being 90 degrees, we know AB and BC. To calculate the hypotenuse AC, we use the 5 steps I taught you last year. First we write down the theorem, then we fill in the numbers we know, calculate their squares, calculate the remaining square, and finished off by taking the square root of our last number. So, AC has a length of 13 centimeters. And if we already know the hypotenuse, we follow the same steps. Just make sure you subtract the two squares at step 4 so you receive the correct answer. As our answer is not an integer, round off to 1 or 2 decimals. It depends on the question. Now that that's out of the way, let's start the first paragraph. I'm going to teach you what cross multiplying means. In most situations, there's a certain relationship between numbers. If you go to the grocery store and buy twice the supplies you would normally buy, you would probably have to pay twice as much. So if 6 eggs cost 2 euros and you want to buy 24 eggs, you can expect to pay 4 times as much as 6, as 4 times 6 is 24. So for 24 eggs, you would need to pay 8 euros. This is what we call a ratio table, and with a ratio table we have something called a cross product. If we cross multiply the numbers, so 6 times 8 and 2 times 24, we would receive the same number, 48. This is a very important feature as it allows us to find the answer even when the numbers aren't this easy. Now let's take a look at this ratio table. 4 kilograms cost 7 euros. So, what does 15 kilograms cost? We know that 4 times this particular number must be equal to 7 times 15. As 7 times 15 is 75, we must find a particular number that multiplied with 4 is 75. So we divide 75 by 4 and receive 26 euros and 25 cents. To do this in one go, we find the cross product and directly divide it by the remaining number. So 15 times 7 divided by 4, which is 26.25. Easy, right? So here are a couple more to help you get the feel for cross multiplications. No kilograms or euros this time, just plain numbers and the letter I want you to find. To find x, multiply 43 and 13 and divide it by 5. Our answer is 111.8. To find y, cross multiply the 14 and 2.5 and divide that by 6 to receive 5.83. Z can be found by multiplying 7 and 9.1 and then dividing it by 0.4 to find 159.25. And w can be found by 1.6 times 2 divided by 8, and this gives us 0.4. Cross multiplying works even with more complicated ratio tables, like this one. Here, instead of an x, we have an x plus 2 in the table. For these exercises, we do need to alter the way we solve these tables. As the cross product needs to be the same, we know that 4 times x plus 2 is equal to 5 times 6. Writing that with the correct brackets will give us this equation. Multiplying out the brackets and solving the equation using the balance method will give us a 5.5 for x, meaning we would need to write a 7.5 underneath the 5 in our table. But as mostly the question is solve for x, we don't need to do that here and end our turn. For the other tables, I follow the same steps. We create an equation using the cross products and solve these equations using the balance method. This will give us a 10.5 for y and a 6.65 for z. Lastly, cross products can even be used for even more difficult ratio tables. Here we have multiple letters in our table, an x minus 4 on top and a x plus 8 below. We follow the same steps. We write down a cross product in the form of an equation and solve this equation using the balance method. And instead of just giving you the answers for the last two tables, why don't you try it yourself? Pause the video, solve the tables for y and z, and then check if you found the correct answers. Did you find the correct answers? Then let's continue on with the next paragraph. Paragraph 2.2, similarity. Easy to understand, hard to master. Here you see three different triangles, but as you can see, they are quite similar, pun intended. The green one is half the size of the orange one, and the blue triangle is 3 times as big as the green one. We can say that triangle ABC, triangle DEF, and triangle KLM are similar. Without knowing the sides, we can also show that triangles are similar by drawing similar symbols in the angles to tell that they are equal. When two or more triangles are similar, we write it with this symbol, a little swirly thing, like an S but lying down and mirrored. When writing down similar triangles, you need to make sure to correctly write down the letters as they don't always follow the alphabet. The first triangle can just follow the alphabet, E, F, G. But as angle E is equal to angle Q, we start with that letter for the second triangle. Angle F is equal to angle P, and angle G is the same as angle R, meaning triangle EFG is similar to triangle QPR. When angles are the same in different shapes, we say that the angles are congruent. Always check which angles are congruent, as this will help you figure out the correct way to write down the triangles. Next up, let's make a table of both triangles with the sides, EFG and QPR. The sides will be written down in the cells on the right. Take note of the order I write down the sides of the second triangle. Side EF is coherent with side QP, so that's the reason why they are in the same column. The same goes for FG and PR and sides EG and QR. Why did I make a table? Well, let me show you. Now we know how long the sides of the first triangle are. Of the second triangle, I only know the side QP, but this is enough information for us to figure out the others. If we fill in the known numbers in our table, we get the following situation. And I just happen to have taught you how to use cross multiplication to find missing numbers in a ratio table. To find PR, we focus on these two columns. Cross multiplying will give us 34.3 as the length of PR. To find QR, ignore the middle column and only use the first and the third one. We use these 4 cells and again use cross multiplication to find a 45.7 for our answer. Let's do 2 more exercises before continuing on with the next paragraph. Again, 2 triangles, a red one and a green one. By looking at the symbols in the angles, we can see that angle A is congruent with angle E, B with D, and C is equal to F. We now know that triangle ABC is similar to triangle EDF. We then make a table with the sides of the triangle. After that, we fill in the numbers we know and we highlight the sides we want to know. We then use cross multiplication to find sides BC and EF. As a side note, you might want to add the numbers instead of just replacing the side names. I know I didn't do that, but I already finished the presentation and I don't feel like changing everything again. So do what I say and not what I do. Next up, a yellow triangle with an extra line. Triangle KLM is similar to triangle PQM as they share angle M. We then make a nice table with the sides of the triangle. We write down the known numbers and highlight the sides we want to know. We want to know how long KP is. And as you probably already figured out, if we know the length of KM and subtract the 10 from MP, we get the length of line segment KP. We focus on the correct columns and receive 21 for KL and 15 for KM. Subtract part MP gives us a 5 for KP. Understood? Good. On to the next paragraph. Paragraph 2.3. Proving similarities. Sounds fancy, but really isn't. In this example, I drew two triangles. Triangle ABC and triangle DBE. But that's just me using the letters counterclockwise. So I'm not really sure if that's the correct way using the similarity rules. I can see that both A and E are 90 degrees, so those are congruent. And both triangles use angle B. And this causes me to conclude that angles C and D must be equal as well. Now that I've proven that the triangles are similar, and I wrote it down, I can make a table. I want to figure out AD and EB. So I highlight EB and fill in every number I have. Line segment AD is not on my table, but if I know the total length of AB, I can figure out how long part AD is. So let's first focus on getting EB. Using the ratio table will get us nowhere, but Pythagoras can help me. As triangle EBD is a right angled triangle with two known sides, we should be able to calculate how long side EB is. After our usual 5 lines, we find that EB is exactly 12. By updating our table, we now have the necessary information to calculate AB. We focus on these 4 cells and use cross multiplication to find AB. AB is 19.2. As DB is equal to 13, that would mean that AD is equal to 6.2. So don't forget about Pythagoras. You're going to need that crazy old Greek a lot more this year. Now let's do an exercise with a story. Everybody loves those. This here is Ben in his backyard. Using similarity, we can find the answer to this question. When the question doesn't provide you with letters, you can pick your own. I go for ground, Ben, shadow, hat and tree. We then have to write down the similar triangles. As G and B are right angles, and both triangles share angle S, we can safely conclude that angles T and H are equal as well. So triangle GST is similar to triangle BSH. We make a table for our situation. Then we fill in our known numbers. We highlight the side we want to know and focus on the cells we can use. We cross multiply and find 9.1 meters for our tree. Paragraph 2.4. Now the fun begins. Sometimes you have to be creative with your ratio tables. Let me show you with this exercise. Kinda similar, again, pun intended, to the previous exercise. So I'll fast forward to the table part. We fill in the known numbers and highlight the side we want to know. But here we face a problem, as to be able to use cross multiplication, we need 4 adjacent cells of which we know 3. And that's not possible as we only know these 2 and we lack the column body of side BE. This is where our creativity will be put to the test. You see, you could say that BC is 6.3 centimeters bigger than BE. So if we set BE equal to X, then BC is equal to x plus 6.3. And now we have this ratio table. This kind of cross multiplication is also something you needed to know in paragraph 2.1. So I expect you to be able to solve this. We write down the cross product in the form of the equation 6 times x plus 6.3 is equal to 8 times x, which we write down like this. We follow the rules of the balance method and find that x is equal to 18.9. As BE was the side set to x, that means that BE is equal to 18.9 centimeters or whatever. Next up, the gradient. If you've ever been to France or Luxembourg or any other mountainy country, you must have seen these signs. Here in the Netherlands, we even use these signs when going up a ramp or something. The numbers on the sign tell the grade of the slope. The higher the number, the steeper the hill. Instead of the grade, we can also tell the gradient. The grade is the percentage of the hill. The gradient is the decimal number that belongs to that percentage. So a grade of 20% corresponds to a gradient of 0.20. The gradient can be calculated by dividing the vertical line by the horizontal line. In math, we call this rise over run. So for this triangle, we do 2 divided by 16, which is equal to 0.125. And that gives us a grade of 12.5%. As calculating a gradient is super easy, let's skip that one and continue on with the next part. Using the gradient to calculate the rise or run of a triangle. Here I have a triangle with a gradient of 0.16 and a run of 7 meters. With this, we can find the correct rise of the triangle. And how do we do that? Correct, we use a ratio table. We put the rise and the run underneath each other and write the gradient in the top right cell. Underneath the gradient we place a 1. We do this to make it easier to calculate, so don't be stubborn and do something else. Just like a normal ratio table, we fill in the things we know and highlight the variable we want to know. And then it's cross multiplication time. 7 times 0.16 divided by 1, which gives us a 1.12 meter. Of course, we can also calculate the run of a triangle this way. We make a table with rise, run and gradient, fill in everything we know, and cross multiply to receive 9.26 meters as our answer. In some exercises, we might give you the grade instead of the gradient, so be sure to rewrite it as the gradient first before filling that in the table. This gives us a rise of 38.4 meters. And now you know how to work with the grade, the gradient, the rise and the run. On to the next paragraph. Paragraph 2.6, the tangent, the first of the trigonometry siblings. Less than a minute ago, I told you about the grade or the gradient of a slope. But instead of that, we could also give you the angle of elevation. But where the grade and the gradient can quickly be calculated into one another, doing that with the angle is slightly more difficult. An angle of 45 degrees corresponds to a gradient of 0.5. And an angle of 55 degrees belongs to a gradient of 1.45. To turn angles into gradients, we have a special function, the tangent. The tangent has its own button on your calculator. So grab your calculator and try it for yourself. Press the 10 button, followed by these numbers. Pressing enter should give you the correct gradient. If by any chance your calculator doesn't give you these numbers, then there's probably a small r or a small g on your calculator screen. If you do get these numbers, then you should have a small d on your screen. If you have an r or a g, you messed up your calculator and you should buy a new one. Or ask your teacher to fix it. We are specialized calculator technicians after all. Next up, turning angles into sides. Almost the same as with the gradient, so I'll go over it pretty fast. Here we have a triangle with an angle of elevation of 67 degrees and a rise of 120 meters. Let's find the run. We start with the same table as before: rise, run, gradient and 1. As the gradient is equal to the tangent of the angle, we fill that in along with the 120 for the rise. And now we cross multiply to find a run of 50.9 meters. Next up, a neon triangle with a run of 85 meters and an angle of 28 degrees. We start with the table and fill in the information we have. Then we use cross multiplication to find the rise. 85 times the tangent of 28 degrees divided by 1, which gives us 45.2 meters. You can also type in tangent of 28 times 85 divided by 1, but be sure to put in some closing brackets behind the 28. If you don't, your calculator might want to multiply 28 and 85 first before going tangent. Another side note, I know I wrote a degree sign over here, but don't put that one in your calculator. He can't handle that, so just type in tan 28. But what if you want to know the angle of elevation? Well, then I got some good news for you. You can calculate that one as well. If you use the opposite of the tangent, you can turn gradients into angles. As multiplying and dividing are opposite, so does the tangent have one. However, we simply call this the inverse tangent. We write it as a tan minus 1, but don't say that, please. To activate the inverse tangent, first press the Shift button on your calculator, followed by the Tangent button. Try it out with these gradients. Now that you know how to turn gradients into angles, let's do that in a triangle. Behold a light orange triangle. We know the rise and the run, and we want to know the angle of elevation. We start by calculating the gradient using our trusty ratio table. Rise over run, so 59 divided by 24 gives us a gradient of 2.458. To turn this into an angle, we use the inverse tangent. Shift tan ans will give us 67.9 degrees. As the gradient isn't exactly 2.458, I use the answer button of my calculator so I don't round off during any intermediate steps. Lastly, a blue triangle. Again, I know the rise and the run and I want to know the angle of elevation. Just as we did before, I start with a ratio table. Rise, run, gradient and 1. We fill in the numbers we know and we highlight the thing we want to know. And use cross multiplying to find a gradient of 0.6. We then convert this into an angle by using the inverse tangent. Our final answer is 31 degrees. And with that final triangle out of the way, I just finished the entirety of chapter 2. Good luck on your test and don't forget to bring your calculator. Bye bye!